Hey everybody, today we're going to solve the insert into a binary search tree problem on LeetCode. This is a pretty common problem. All it is asking us to insert a value into a binary search tree. We could read through the description, but that's what it's asking. Here's what an example looks like. We're given the tree 42713 and we're inserting 5. Then there's a couple different ways you could do this. You could return this tree right here. 427135, 5 inserted at the bottom. This is also valid 527134. What I'll say is, as far as writing code and everything, this is much more difficult, a lot more involved than what we're going to do. The simpler way is just inserting at the bottom here. They're both valid and correct, so either one of them will work. The way we're going to do it is we're going to start off with this tree, and we know we need to insert 5. First thing we're going to do is search for 5. So we'll basically traverse through the tree. We're not going to find it, obviously, because it's not there. And eventually we will hit an empty spot, and then we'll just attach it on the end. Okay, so we're going to say, okay, where's 5? Well, 5 is greater than 4, so we'll go to the right. We'll hit 7. Where's 5? Well, 5 is less than 7, so we'll end up over here, and we'll just end up sticking it onto the end of 7 right there, just like it has in the example picture there. So in order to do that, we need to keep track of a couple of global variables. A tree node, which we will call prev, or previous. We're going to keep track of the last valid node that we saw. And left, which we'll just initiate false, is going to determine if we're coming from the left or right of that previous node that we saw. So in here, we'll call search BST, which we'll write in a minute, from the root, and val. Make a new node. With the value that we were given. And then we just need to stick it into the tree. So if previous is equal to null, this means that we were given an empty tree. So if we're given an empty tree, then we were just going to return our new node, because it is now the only node in the tree. Otherwise, if left, meaning we are going left from the previous value that we saw, then previous.left is equal to new node. Else, meaning we're going right from the previous node we saw, then previous.right is equal to new node. And then down here at the bottom, we will just return the root, because then with the root of the updated tree, and we've updated the tree at that point. And then all that's left is to write search BST, which is pretty simple. Alright, just a recursive function. If root is null, just return our base case there. Else, if root.val is greater than value, then that means value must be to the left. So update our left to be true, keeping track that we're going to the left. Update previous to be the root, because it's now the last valid node that we saw. And then we'll search BST with root.left and val. Else, meaning root val is less than val, meaning we need to go to the right. Obviously making left false, since we are going to the right. Prev is root. A little bit of code duplication, that's okay here though. And then we'll search BST, root.right, with the value. Looks good there. And success. That's all there is to it. So when you're inserting into a binary search tree, You're given a tree, you're given the value to insert. It's a two-step process. First, now we did have a guarantee in this problem that the new value does not exist in the binary search tree. Okay. If it does, it could make things a little different for your algorithm, but overall, the algorithm in here would be a little different, but it would still work out the same way. So we're given this tree, this value to insert. First step is to search for it, which we won't find it. It'll get us to the place where we need to insert it. Just remember the previous one you saw and attach him onto the end there. And that's all you have to do.